Welcome, everybody, to our 129th AiM Sports Learn Fast webinar. In this series, we've been having a great time talking about all different parts of our world, including some more entertaining ones with some folks that talk about their data use, some about hardware, so a lot about Race Studio software, and today we're going to talk about a topic that I've gotten a lot of comments on and wanting a little bit more detail, and we've been planning to do them all along, and this is the next one, so we're looking forward to this one. AiM Sports CAN ECU driver builder features update. We've got our valued co-host here again with us. Robbie Yeoman is going to be talking about the ECU driver builder and kind of walking us through a process of some of the features that are in there now. That there's been some updates. I'm going to talk about some of those and walk you through a couple of examples, and then of course take your questions and hopefully get some answers for those. If you're watching later on YouTube, down in the description box, any links he talks about, any links that we put up for the folks that are watching here live, will be available to you in the description box below. So with that, let's introduce Robbie and bring him in here. Robbie is an AiM Sports technician, been here for virtually forever, right, Robbie? Since 2008. A guy with a passion for racing and electronics, so he's in the perfect place. Been doing a lot of custom wiring work and of course data systems on the chassis side. Has been co-host here with me many times, but even more in the background, helping with throwing links into the chat box and just helping support the entire program, which I thank him for very much. Thank you, Robbie, for joining us again here today.
Oh, absolutely. This was a long overdue. We had a couple of great webinars that we did with Jeff Wasilico and CAN 101 Part 1 and 2. And this is just basically growing on that theme. And I'm glad you had a time slot for me.
Absolutely, and we see live Robbie over in the picture is back to having the beard, and it's always a shock to some of us that when we see him at the PRI show every year where he shaves off his beard. So, but you're coming back, slowly, right?
Slowly, yeah.
back to the full beard. What I'm going to do now is we're going to turn this over pretty quickly to Robbie and his screen. Again, for those of you here live, if you have some questions, we've got some built-in time for some of those. If Robbie's talking about something and you'd like a little bit more detail or something, make sure you throw them into the question and answer box, and then Robbie will either take a look at them or I'll feed them in as we go. I also had a couple of email questions that I got during the last few days as we were kind of getting up to speed and getting ready to do this one, and we'll fit those in as well. So I'm going to stop the share on my screen, and Robbie, you can share your screen. We will be up and running.
We're over to my share. All right, that's looking better. Hopefully everyone can see it.
Yep, I can see it on my other computer. You are up and running.
Okay, so first what I wanted to talk about was just where we left off after CAN 101 and CAN bus basics. So we have already discussed with the building CAN output using a solo 2DL and taking the data from an ECU, sending it to another device, and then reading that information. So that required us to send the data via CAN output and then receive it in via an ECU driver file, an XC1 using ECU driver builder. So to do that, we went over the filter mask, we went over the function sets, we went over RPM and temperature. So that is all done in the ECU builder section of the software. So when we create a new one, we have all these options, and we have to organize all of this computer language into usable units that we can understand. Part of that was going over step function, sign notation, encoding value, gain, and force values for testing and validation. In the CAN bus basics, we talked a lot, high-level overview of what is CAN bus, and if any of the things that I said previously do not make sense, there is an order that these should be watched. And so I think you should start with that AiM Sports CAN bus basics with Jeff Wasilico. We did a great job going over the high level networking of a device and why we chose to pair certain things together, and an explanation of how you physically connect them. Some of the errors that you might have, troubleshooting. Just a great getting into CAN bus webinar. It's an hour long, but it's worth all 60 minutes of it.
And I will put those, the links are in the chat box for those of you watching here live. You can copy those out and save those, or they'll be in the description once we get this up on YouTube, and I'll try to put those in the order that you just described that they ought to watch them.
So then I would watch the CAN 101 Part 1 and CAN 101 Part 2, where we discuss the encoding of data from a solo system that's receiving ECU data and sending it out to, in our example, it was an MXG, and then we received that information in, recoded it so that it had a unit and made sense to us, and tested it and validated it. So if you were going to watch them all, and this is your first foray into CAN, it would be the CAN bus basics, CAN 101 Part 1, and CAN 101 Part 2. Or I think it's called Intro to ECU CAN Builder.
Yeah, exactly.
That's the Part 1. That's the Part 1.
1-27 is the first one, then 137 is Part 2, and then the last one, 2-9, we've numbered them all, and that was the CAN bus basics with Jeff. That was very, very valuable.
All right, so today I would like to further expand upon that with a worked example. So to get this started, we have what I like to call the automotive Internet of Things. It is all these CAN hardware systems, and before it was just your ECU or in the data system that were CAN operated. Everything else was analog. We would run oil pressure sensors and oil temp sensors and everything that we couldn't get from the ECU or didn't care to manage. And now we're going from this analog format into a more digital format, and it's much easier to install, it's much easier to manage, but everyone has to have a knowledge base of what this CAN is. And my hope is to take this worked example and show you guys some problems that you may have. So I have a couple of things. I don't know if you can see well my icons, or my avatar, my live person, but I have lots of things. I have a Blink Marine PKP 2600 keypad. So great integration piece for the PDM, and it allows you a user interface that says, when I push this button, I want to send power out, or I want to do something. I'm going to page command. This is a user interface CAN system. Then I also have a GPS module. This comes with almost all of our data logging systems, and it plugs into our proprietary CAN bus. These you don't really have to configure. They are built and ready to be plugged in. And then I have a data logging dash. We have an MXG here that has 3 CAN buses, and we also have our PDM, which we will be using the configuration software for today. And we have a tire pressure monitoring system. And what is not present that we'll be using today is a battery isolator. So I have all of these things, and on paper, it seems like the PDM just doesn't have what it takes. The PDM just doesn't have what it takes to get the job done. We have 3 CAN buses, 2 of which you can modify as end users, and 1 that is proprietary to our devices. So that takes care of our GPS module, it takes care of our Smarty cams, and we are able to seamlessly integrate those without any type of configuration support. You just go in and say, I have a shift light module, I have a Lambda controller. The keypad and the tire pressure monitoring system and the ECU and the battery isolator are all CAN accessories. So how do I fit all of that information into 2 CAN buses on the PDM? That's the problem, and that's where most people they stop and they want to add a dedicated CAN bus. This has a bus speed by default. The keypad has a bus speed by default of 125K. So we need to change this to match our tire pressure monitoring system, which is 1 megabit per second, and our battery isolator, which is also 1 megabit per second. So if you remember when we did the webinar with Jeff Wasilico, we talked a lot about bus speed and how to get all the devices working. Requires that they have the same bus speed, or you will shut down the CAN bus. It will no longer function, and most of the times we don't get any type of lasting faults. So setting the wrong bus speed on a sniffer or a device will shut it down temporarily. You remove the offending product and reboot it, and everything works a-okay. Let's start with the problem. We have this keypad, and we would like to set it to match the bus speed of our tire pressure monitoring system and our battery isolator. The idea is to keep it on CAN 2 and let the ECU be isolated on CAN 1. So to do this, we want to make sure that we have the right keypad. So to match our configuration interface, it needs to be a CAN open keypad. It needs to have the matching bus speed, and it needs to have the correct node ID. So when you
Do
order
most
these,
of the keypads out there have that ability, Rob, to do what you just mentioned, or is there really just a couple of big manufacturers?
there's a couple of big manufacturers, and most of the keypads that you see out there are flavors of those manufacturers.
Gotcha. So you can do pretty much everything you're talking about with most of the ones that are out there.
Absolutely. So we're gonna be focusing today on the Blink Marine PKP series. So how do you change the bus speed? Where do you get this information? Well, we go directly to the user manual. This is available most of the time when you buy an accessory CAN device. You will get some type of CAN infrastructure. Like, this is how we send our data, or we are expecting to receive the data. So you peruse through the summary, the index here, and first thing that catches my eye, we got an activation message that we have to respect. So I can click here, and I need to tell the keypad that it has to turn on. So to do that, I'm going to set the identifier. This is the CAN ID. I'm going to set it to 00. So I do have a configuration here that I use for keypad adjusting. This is how you can use your PDM to adjust the bus speed on a keypad, and also set the node ID. So we know that we're in CAN open. When we bought the keypad, it's CAN open or J1939 or motorsport specific firmware, and some of these things may differ because of the protocol that we're using, but the idea is the same. So we want to take a blank PDM configuration here, and I want to set the CAN 1 or CAN 2, whichever I physically have the keypad plugged into. I want to set that to activate the keypad, so it will turn on. It's a requirement before we can do any work. So I just simply transpose my CAN ID 00, and I put it in as my CAN ID 0, and then I enter in these static values. So 01, 01. The things to note is that everything I've written is in hexadecimal, and it's denoted by 0x. So when I'm typing these values, I actually add a 0x1, and that one in hexadecimal and decimal is the same thing, so that's not a problem. But if I did something like 13 or 20, then it has a different decimal value than what you're reading. So we set it to 0x1, and we set the CAN ID. Now this, I only have one keypad, so I want to use this global command. It starts all the keypads regardless of the node ID. I would like to just use this so I don't have to go back in and edit it once we change the CAN or the node ID. So I'm going to use the global address. I enable this, and now I can transmit just this message right here, and the keypad should wake up. It goes through its LED sequence. Everything seems to be functioning normally. I need, because of the software commands, the CAN2 keypad settings, I need to assign the node ID. So if you remember, by default, the CAN ID is 15. So that's not going to work because that's defined as an 8-button keypad in our software. We need to set this node ID to an ID of 19. That's the first available keypad that we can use that is of a 12-button configuration. So we have to set the node ID. To set the node ID in this manual, you will find that there is a node ID setting. Let's see, I think it was 20. No, that's baud rate. Yep, node ID. So to set the node ID, it's another CAN message. all we have to do is transcribe this information into our CAN output. So if I could just break this down for you right here, this is the CAN ID. When you read this, it's 600 in hex plus the current CAN ID of the keypad. So in our case, we know that it's a default ID of 15. We know our CAN ID is going to be 600 plus 15. We arrive at 615. This is how you talk to this specific keypad. From there, we have some static values. Now, these are, you just add them in. You can disregard them, but it's 2F 13 20 00. These are how you access the menu structure within the keypad. So we're now telling it, okay, we're going to try to change the node ID. I need to send these messages, and then I need to send an action here. So that's my byte 4. So I fill these out, and on my byte 4, I want to set my new node ID. So you can see it supports 01 in hex to 7F in hex. I have a very specific node ID I want to achieve. So I will be adding in a value of 0x19 to send a node ID change to this keypad to go from 15 to 19. So once this is complete, I transmit it to the PDM, and we send the activation message. The hardware wakes up, and then it gets a request to change its node ID to 19. At that point, we're done. We have set the node ID. What we still have yet to do is allow it to communicate with our other devices. Our battery isolator is at 1 megabit per second, and our tire pressure monitoring system is also at 1 megabit per second. So we have one last message, and it was the bus speed message. So to set the bus speed message, we are going to disable our 615 node identification message and enable our baud rate setting message. I've already written all these out, but it's the same idea. We have a 600, and this is where it gets tricky. The 600 ID is plus the current CAN ID, but we just modified the current CAN ID to 19. So our new CAN ID to talk to this keypad that has been reprogrammed as ID 19 would be a value of 619. This is a way to hit this keypad specifically. So what we're going to do is enter our static values, the 2F 102000, and we are going to use byte 4 as the change command. So I'm going to look at what makes sense for us. I have options here: 125, 500, 250, 125, 50, and 20K. We want 1 megabit per second, or 100K. So I'm going to fill in this byte 4 with the value that makes sense for my application. And the static value would be 0 in this case. So I want to bump it up to 1 megabit per second to match all my other things. I transmit this to the PDM, keeping the activation message so it looks on, or so that it turns on. And once it's received, it updates the bus speed, and we're ready to go. I now have a 1 megabit ID 19 keypad.
Got a couple of questions that happened in the chat box there that maybe you can answer or even comment on again. So, Matt mentions that something that confuses some people is that the baud rate and the bus speeds are the same thing. Those terms are interchangeable a little bit, right? So everybody just kind of keep that in mind. And then Todd mentions, I think I missed why you were changing the node ID.
Okay. So, well, Matt, I interchange them back and forth.
That was from Todd. That was from for the terms, and then Todd's
for the terms.
question.
I will interchange them. I will also call it encoding and decoding data. But the reason that we had to change the node ID is because from Blink Marine, when you order a CAN open keypad, if you've not told them to modify these settings, it will come as an ID 15 by default, and it will also come at 125 kilobits per second, and that's not what we want. In this application, we need this to be an ID 19, one for our software, because our software is set up so that you can run 4 keypads that are 8 keys, but they have to have different IDs so that we know that the buttons are different. This is button 1 of keypad 2, or button 2 of keypad 4. In this case, we have 1 keypad, but it's ID 19. So we're going to set the keypad to ID 19, which is what we just did with the CAN output section.
Perfect. Yep.
So that was our set of the 19 keypad. Then we adjusted our CAN ID to match our new ID, so 600 plus node ID is 619, and we are setting with our byte 4 value to 1 megabit per second or 100 kilobits or 1000 kilobits per second. So once I transmit this, we're now at 1 megabit per second and ID 19, which is exactly what we need it to be in. So here's where we go into our other configuration. We will need to save that.
While you're loading that back up, Kyle has a newbie question. He says, total newbie to the subject. Are these config messages sent every time the system is on continuously, or is it just a one-time thing? So you're programming the AiM dash to send these to the other components in the car's power up?
Yes, yes and no. This should be done
Exactly.
in a controlled environment. So at this point, if I wouldn't use the PDM myself, I have other tools that make it much easier to set scripts and do these types of things like automated. But most people don't have those tools. So this is using a current tool that many people would have to kind of tackle a project that they need to have solved. So in this case, yes, we are broadcasting the message at 1 time a second continuously to the Blink Marine keypad. And for the duration of it, that's why we use a blank config. I don't want any power outputs, and I don't want anything else connected to the PDM. To be quite honest, I'm going to connect it to the CAN 1 or CAN 2 bus, and I'm going to do all the work on the keypad in a blank configuration with nothing happening. So that's why that's the configuration we use is one that we pass around in the offices when we need to do work like this, because it's a blank, it's completely blank.
So all of the work you're doing here is just a configuration thing. It's not a final product that is going to be out there.
Right, and we're now done with that configuration, so it's a one and done type piece.
And now and resides now on the blank on the keypad.
Mm-hmm.
It's been set up.
So we have all of our devices now communicating at the right speed. We had our battery isolator at 1 megabit per second. We got our tire pressure monitoring system at 1 megabit per second, and now we have our keypad at 1 megabit per second. But how do we get the data from our other devices, the tire pressure monitoring system and the battery isolator? How do we get those into the CAN 2 stream? We can't just physically connect them. We need to build a mix-up of ECU drivers. And I'm going to tell you how I solve it. We're going to go to the websites for the manufacturers, and we're going to look for DVC files. So here I have the MSEL CAN Communications template database. So I can just click on this, it downloads it to my computer, and I have a DVC file for the solid state battery isolator.
And that's pretty universal, that virtually every piece of hardware that people are buying that are CAN driven have these files that are available for you.
Yes, it's our hope. It's our hope it doesn't come in an Excel spreadsheet and that they give you a DVC file.
There you go.
Now, if it does come in an Excel spreadsheet, our other webinars on ECU Driver Builder will help you transpose that information over. But in this one, we wanted to show some of the new features of ECU Driver Builder. So next, we have the tire pressure monitoring system. We're going to use the ALS Tire Pro. Also has a DVC file that can be downloaded. And I did cheat a little bit just to save time, but I'll tell you what I did. I took both of these DVC files and I put it in my DVC editor, and I created one DVC file from them. So I just put them together, and there are a lot of software programs out there that can do this, and most of them are free. So you can get a DVC editor and put 2 DVC files in there, export the new DVC file as one, which makes it really easy to get into our software and our next step in the process. So we have to take this DVC file that we have and import it into the software. And before, we would have to do it longhand. We would have to open it up in a DVC editor and Notepad and manually transcribe the information that we had from here into our software. But our software team has solved another problem for us once again, and they gave us a DVC protocol file import tool. So I want to be able to click on this import and import a DVC file. I can locate the DVC file from wherever I house it, and I click open, and it runs through a validation check, making sure everything's okay. Now we're back to the new custom protocol section that we found in our other webinars, and for the naming convention of something like this, I like to make a new manufacturer because I can't say that it's a battery isolator and I can't say it's a tire pressure monitoring system, and it's certainly not a keypad. So it doesn't really fit into it. I use the vehicle name quite often. So if this is a specific vehicle, I put the manufacturer in of the racer, the vehicle number, something like that, that can allow me to identify it when I'm looking through the list of available CAN drivers. So for this one, we'll put it under AiM, and it needs a name. So we'll call this DVC to CAN for our webinar, which already exists. The CAN device type needs to be set to this other CAN devices. This is your CAN 2 stream. So we're telling the software that this is to be located on CAN 2 and not available on CAN 1. So this would be our CAN 1 and for us, we're other CAN devices. And now we know our bus speed because we've done all of the programming to make sure that everything was working. We're going to set this to 1 megabit per second. And we hit OK. It comes through and we get a new protocol validation tool. This is going to take the information out of the DVC file and start converting it into an XC1 format. But it can't do everything. What it can't do is assign the functions that we use internally for water temperature so that it goes to a SmartyCam, or for RPM so that it goes to a SmartyCam, or the integration that we have with these functions, math channels and RayStudio 3 analysis, all use this function set. And then the naming convention may not work to your liking. So what we can do here, and we'll do a couple of them. So we know that this is sensor 1 channel 4 from the DVC file, sensor 1 channel 6. Maybe my sensor 1 is the right rear tire, and then we'll call this channel 4. So this is our right rear tire, channel 4. The short name is what gets displayed on our hardware when you're looking at it. So we want this to say RR4. And we set the function to temperature. And it's just a generic temperature. We don't have one dedicated for the tire pyrometers in this case. So we will set that. The default unit is in Celsius, and the unit in the DVC file is also in Celsius. So we have effectively set up this channel with all the information just from a DVC file. Now in here, you'll see that there's 2 buttons, one through 50, just to keep the scroll function to a minimum. And then the residual goes into 51 to 100, which I don't have that many, so we will.
But these files can get very large, right?
They can be, yes, they can be. Should see the one I have for Tesla. It's massive.
There's a couple of questions that I got during the, and maybe this is a good time to slide one of them in, on Facebook when we were talking about this was going to be our topic. I got a question from Harry Adeline. He's not able to be here today. Is there a way to make the existing XC1 files? We're building this XC1 file. Is there a way to edit existing ones?
To edit existing XC1 files?
Yeah.
Not yet, but we're actively working on an amendment option. We're stuck in a lot of business to business relationships that we've produced. We've been given proprietary information under the assumption that we will not be sending it out to other people, and so we've been trying to wrap our heads around how we can possibly make this easier without offending any of our business partners. So what we have thought of is an amendment option. So you won't be able to see all the work that we've done either through reverse engineering or through protocols that were given to us. But what you will be able to do is add to an existing database file. So you would create an XC1 file like you normally did. This is the information that I know is there, and you will attach it to your ECU stream. So if I have an ECU and then I also have a tire pressure monitoring system on the same bus, I can take the ECU stream that we have already done through either reverse engineering or protocol being given to us and add another device to it.
So you're not truly, the other question Harry had, will there be a list of AiM protocol files that are editable? There won't be, because there is not going to be a list that's truly editable, but there's going to be this process where if you've got something else you want to put on that CAN stream, you'll be able to add it to it. Right. So okay, that makes sense.
because we spent over a decade developing our ECU database, and a lot of it it's labor intensive. Not physical labor, but it requires a tremendous amount of time.
Absolutely.
So we don't want to give it all away. There are some that we can share, that we have the freedom to share. It's either our intellectual property or it's come from what we've been doing today. We've been pulling DVC files off the internet today, and these are already out there, so we could share those without getting into any trouble.
But generally speaking, we've imagined a process where this amendment thing is probably a really good solution.
Mm-hmm.
So okay.
So we have been setting up our tire pressure systems, and we're not going to do all of these because this is just a rinse and repeat exercise. We are taking the name that we want it to have in our data and the short name, which is what we want it in the display, and we're setting the default unit coming out of the hardware, and we're validating it. The checkbox here validates it in the ECU protocol so that we know we've already looked at it and we've confirmed that the translation between DVC and XC1 is correct.
And you walked your way down through and check them, validate them.
We go through all of them, exactly. And there are other ones in here, and can kill or some of these are they don't have a unit. So you could use a number, you could use a code. There's a lot of different ways to solve this this option. But if I wanted to set like an encoded value for when can kill is on or can kill is off, I can do that. And we discussed it pretty heavily in our CAN 101 part 2 topic webinar. That's what I meant. So so we'll just continue down. We're setting these. If we have a database file, then we know that it's in Celsius. We can set the temperature and the units correctly. But for now, we're just going to validate all. And we are going to see what that looks like in the end. So we hit validate all. And we have this DVC to CAN ECU file. If I open this up, it has now correctly transposed all of the information from my DVC file to an XC1 file, and I didn't have to write the start bit. I didn't have to write the bit length. I didn't have to do the gain. I didn't have to do the offset. I just had to go through and check that the units were correct and to give it a naming convention that I want to use.
A huge time saver for users.
Absolutely.
Not just Robbie, but for all users.
Mm-hmm. So here we can see that I have a couple of different messages, and you can almost see the differences here. So these all come from my my ALS Tire Pro system, and they're sequential: 222, 223, 224, 225, 226, and then I have the battery isolator uses a different convention. We have a 64 and a 65. So there's no conflict here. We don't have any issue mashing these up, but you can actually see the devices just by looking at the CAN IDs.
So the bottom line, the most important thing is to get them all on the same speed, and then when you begin the process of putting these together, you've given them different CAN IDs, and they seamlessly slip together into this file.
Yes, exactly. And,
Perfect.
And now we've almost solved our problem, which was how can we get 3 devices of different bus speeds all onto the same CAN bus and communicating appropriately. So we have now a way to read all of our data from our tire pressure monitoring system and a way to read all the data from our battery isolator. And we've coded all of that information, and it really took not a whole lot of time. I mean,
not very much time at all, and we were talking our way through it on top of it.
So the last thing to do when we're happy with the way everything looks, and these can always be edited again. So if I wanted to do a different sensor, or I lost the sensor and my configuration needs to change, I can always come back in and edit these. And there is some really nice things about using a DVC file that aren't present when you're building from scratch. The info from DVC file here gives you the name that was in the DVC file, the start bit, the length of the message, the Indian type, if it's signed or unsigned, and the gain factor, offset, and the minimum maximum values that you can expect in the base unit that it's in. And this is pulled directly from the DVC file, but we present it to you so that you can, if it's not working right, you can always come back in and make sure that these parameters have been met the way that we expect or we need them to be. So
Very
here
good.
you can see we have assigned integer format for our data format. That's because this is a signed function. Is signed? True. Yes. So we put this to signed. We have a gain of 0.1. This has a factor of 0.1. We have an offset of 200. This has an offset of 200. So we have done everything that we can to make sure that the start bit, the length, the gain, the offset, the data format are all the same from the DVC file. And I can come in and still re-edit this. So let's say this is my front right. And then this is front right tire 1. And then we can do the short name as well. But this should be done all in the DVC validation process.
You just didn't go, you only did the first couple of lines.
I only did the first couple.
Yeah.
All right, so if we're happy with the way that this is looking, then we can go in, we can save it, and we can put an end to our CAN builder section, and we can come back into our configurations, where we now need to set some parameters for all of these to work. So first and foremost, we have to set the CAN2 stream. So I want to use this DVC to CAN1 that we just created. And I'm going to hit OK. And since I'm replacing it, it prompts you, do you want to move the names around where they see fit? For this, we're not going to be worrying about that. But this is saying that we have a keypad selected here. This is a warning because this happens all the time, that the keypads, for the keypads to work, they have to be changed. By default, they come with a configuration that this will not work with. So we've already gone through those steps. We can disregard this message, but that's why this message is here. So we set our CAN2 stream to the XC1 file that we just created, and we go into a CAN2 keypad. So we know that we also set the node ID, and we set the node ID to 19. If I had set it to 1A, we would be using this option, or 1B, we would be using this option, and we fill out all of our keypad information, knowing that it's at 1 megabit per second, and our CAN2 data is still all present and accounted for. So this would be how you effectively manage your Internet of Things.
Interesting. I did not know that.
Yes.
Eric has a question there. Is there a reason we don't have the ability to use CAN2 out the same time keypads are configured?
Yes, yes, there is. And if you can see this manual, we addressed, so in setting the node ID, the bus speed, and the activation of it, we have addressed only 3 sections of this. This keypad requires a heavy amount of traffic to be sent to the keypad to control it. So the keypad, all it tells me is that there is a momentary press of this button. It is the responsibility of the device, the PDM in our case, to send the LED state to the keypad, to also send the function of the button, whether it's a toggle, a multi-position, a locking, and then the respective colors for that. All of that requires a message to be sent to the keypad. We receive a momentary click, and we have to read that information, process it, and send back to the keypad what we want it to do. Given our programming. That's why we put this CAN2 keypad user interface in the software, because nobody wants to go through this document in its entirety to make sure that you can get your LED 1 red, but when you press it again, you want it to turn blue, and then you press it again, and then you want it to turn white. It's a long process.
Yeah. Okay.
So for simplicity, we disabled the CAN output because we need it. We're relying heavily on it to talk to the keypad right now, and that's why I don't have a problem with the tire pressure monitoring systems, the keypad, and the battery isolator together, because they're all passive devices. They're broadcasting information, but they don't require me to send any information to them. So that's why it was part of my my planning process. When I have all of these CAN operated things, you have to sit down and think about what CAN traffic is traveling from one device to another device.
We do have a question in the question and answer. Robbie, maybe you can handle. Is there a timeline to expand the 80 channel limit in CAN2 to 120 or more, like CAN1 has?
A timeline? No, It is on the
It is on the
ever-evolving list
Okay.
of things to accomplish, and we would love to accomplish all of the things on that list. That's
Yeah.
why we made that list, is to make sure we knock all of those out. But when we will actually finalize a function like that, I'm not sure.
Okay. Perfect. We're not too sure, but it is on the list. Mr. Tech. It doesn't have a name. It doesn't have a name. So perfect.
So so we do have a little bit of time. So I'd like to, I know we went really fast through this, but I was really relying on our other webinars that we've done on the subject to basically get you guys up to speed. But if you had any questions, I'd love to address those right now. If not, we can go over some other added topics that I have lined up, like keypad color functions, status variables, and trigger commands.
Why don't you handle one of those, and let's see if we can get a couple of questions, a little bit deeper questions about some of the stuff we've covered.
Okay, so we have our CAN2 keypad, and we've set it up to ID 19 and change the bus speed, and we got our CAN2 stream going. Now it's time to set the keypad up, and this is one of my first steps with any PDM configuration. It is to establish what I want the keypad to do, and if you don't start with the keypad, it becomes you're doubling your efforts, because I set a power output. I don't have a keypad function to tell the power output what to do. So now I got to go back and set the keypad function. When I set the, if you do that, you're going back and forth between the software. Just get a good idea of what you want the keypad to do, how you want these buttons to function, and set them up. So for here, we have the start switch. This is just a simple momentary button. When I push the button, for as long as I push the button, this will be on. When it's not being pushed, it will be off. And I'd like to have some type of backlight color on the keypad, so that one, I know it's active, and I like to use a solid standard color for all of my backlights to let me know that the keypad is not activated. That button is not activated. So I set these up with a priority message function, and to add priority messages, you just click on this gear icon here, and you can add a new output state. So we will actually work this example. So I'll maximize that to the top priority. And the way that you would read this is from the lowest priority up. So I have set the status value to white when the following condition is verified for at least 0 seconds. So the second I push it, it should go from, well, it's the second this is true, it should be white. So at initial boot up, I'm going to have a white backlit button. Now when I push the button, so start switch equals to on, I want to set the status to green, and I want that to happen immediately. Now, I also want to know if there is a problem with my starter, and I don't want to download the data to do this. So I'm going to set a red indicator, and I'm going to use my power output status, and I'm going to say if my starter status is different from 0, I want you to turn this red. And now starter status is a bit field, where each bit has a unit that, or each bit has a definition. It's like an error reporting. So when this bit is on, you have a short circuit. When this bit is on, you're over temperature. When this bit is on, you are over current, or this bit is on, you're an open load situation. So we don't have a ground.
Tons of different things can actually trigger the one. If it's not a 0, you have a problem.
Yes.
Turn it red.
So 0 is good. 0 is everything is working. If any other number is present in that bit field, I want to turn that keypad red. So that way I'm sitting there and I'm pressing it, and if it goes red, I know that I have a problem in the wiring to the starter relay or to the starter solenoid, or something has happened with the way that I'm trying to send power to this.
Interesting.
And that can be applied. This type of priority can be applied to all of your buttons if you just manage the priority correctly. So if we come down to something like this, let's see, fan speed. I had a Parker pumper that was recently had a variable speed controller on it. So I took
that's an off-road for those of you road racing guys. That's an off-road term for the pump that sends fresh air to the driver and co-driver's helmets.
So fresh air to the helmet. So it had a dedicated power, and a variable speed controller. So they sent this big box. I mean, we're talking almost the size of the PDM,
Really?
and it had a dial on one side and an on-off switch, and it was like, where are we going to put this? I was like, don't even, just take it out. Yeah. Yeah, so don't even worry about it. Take it out, and I use the half bridge output to send a pulse width modulation to the Parker pumper. But I wanted the user to have some control of what the speeds were, so I set my pulse width. I basically just made my keypad reflect the levels that I wanted to have. So I have off 25% duty cycle, 50% duty cycle, 75% duty cycle, and 100% duty cycle. Then I set my short presses to advance to the next. So when I just quickly tap from the off position, it goes to 25. When I quickly tap from 25, it goes to 50. And when I quickly tap from 50, it goes to 75, 100, then goes to off. But I also use the timing command with two different states. So if the hardware, excuse me, if the hardware is off and I'm not sending variable control, then when I long press it, I want to turn the pump on at 100%. And any other time that it is on, I want to long press it and immediately take it to the off position. So, and that's just a usability function. It's just something that the driver wanted to be able to turn it off without having to cycle through all of the states. And it gets pretty wild when you have 8 or 9 states to start on map A, and then you're on map H, and you got to go all the way through the list to get back to B.
Yeah. The what I see here is it's we have a ton of configuration power, right? Where this we're giving the user a bunch of configuration power, but it really comes down to the user imagining what they want to do. I see the same thing in alarms. People will ask sometimes, well, yeah, I got a high water temperature, just turn on a light. Well, there are other things you can do. What is in your mind? Do you want it to turn yellow first and then red and then flash and then the entire screen go? Well, we allow a lot of things like that, and what you've just shown there with these keypads are the same thing, not only with the lights on the background, but the multi-position, the momentaries, all of these different things. The user can use their mind and say, well, how do I really want to make this individualized for me, to make it work exactly how I want it to work and do what I want it to do, and then boom, we can handle that. Very, 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 very cool.
Yes, the imagination is the limiting factor here.
Exactly.
And I struggle with it all the time. I can build you something that works, and then what I like to do is sit down with whoever's responsible for touching all these buttons and doing all these things, and I'm just like, what would you like it to do? Let me use your imagination for a second.
I can't tell you how many times I've said that same thing. Just leave your realm of what restrictions you think you have. If, boy, in a perfect world, what would you like it to do, and can we do it? And often we can. So very, very cool.
Yep. And then there is one other thing. So we've gone over the colors, we've gone over the functions, the multi-positions, the toggles, the momentaries. The naming convention is something that is overlooked. So you can call this I can call this pumper, or I can call this start. The problem is when I go to my power outputs, I can no longer use that function. So I always, when I'm doing keypads, will assign what they are doing. So start SW, it's my start switch. Push to pass switch. Headlight switch. And I know when I'm looking through a list on either in data or I'm looking through a list in the configuration software, I know that my switches are user inputs. These are my toggles. These are my my keypads. These are all what the user is going to interact with. And I do the same thing with status variables. When I create status variables, I put an SV at the end of them.
I was actually just going to share that, back to where a lot of people have been working these status variables or triggers or alarms. It becomes a very, very good habit to append what they are beyond the name, because it will help you. It gets really you can build so much again that you need to handle that into the naming side.
Yes, it's a hard lesson, because I learned this lesson the hard way, because I would design my keypad with no naming in, and then I'd get into my power outputs and I'd say, okay, my start. Okay, well, start's not available. Starter, start one. You just go through and you're trying to figure out all these different names, and then at the end you have an unreadable configuration where it's just very difficult to go like, what was start one? What is
becomes frustrating and hard for anybody to follow along behind you either, right? So it's this makes things much easier.
Right.
Good tip. Good tip.
Yeah, so then I had a couple of customers that wanted to notify the people in front of them that they were approaching. So this is why I have a push to pass switch in here, and it's set up as a toggle. And when we assign the button's pretty straightforward. When I push it, it goes on and it stays on. So it latches in that on position, and it requires me to push it again to turn it off. So when this happens, I can actually use this button to handle a couple of different options. So first, I can enable my siren to be on, and then I can also I can pulse the power on and off to the headlights or to the A-pillar lights or the light bar or whatever I think that the person in front of me is going to see. So how do you do that, right? How do I get one button to basically create a pulsing signal and an on signal? And it's like, how do I make this toggle switch a momentary and a square wave and all these things? And the answer is status variables. We can create a status variable. I call this the wigwag. And when you open it up, you can see that it's a momentary option. So when my push to pass switch is equal to on, I want to generate a square wave. Now, my push to pass is a toggle switch, so I don't need any of my other status variables that relate to this push to pass to be set up as a toggle. I want them all to be set up as momentary because the latching mechanism is done at the keypad.
Prior, yeah.
So I will set this up to momentary, and as long as it's true, as long as the push to pass switch is on, this will be true and this will activate. What this is going to do is generate a pulsing signal, an on-off signal at durations that I can define. So I'm going to come in here and define my durations at 0.1 seconds. So I want 0.1 seconds of on time, 0.1 seconds of off time, and then just repeat that over and over and over again. And that's how I'm going to blink my lights. So we set up our status variable. Now I want to take that status variable and create a wigwag of the headlights. And for this, we're going to use the power outputs directly to the headlights. And I have a driver headlight here that I've set up, and I set it to pulse width modulation, not because I need pulse width modulation, but because I have priority control in pulse width modulation. So if you notice, my duty cycle is at 100% and 100%, so it's just sending constant power, but now my logic is set to respect my this priority here. So when my headlight switch gets turned on, the headlights turn on. Perfect. That's what I want them to do. But when my wigwag status variable is true, I want you to pulse the lights. And I want you to look at that square wave that's being generated and just pulse on, pulse off, pulse on, pulse off. So I set the driver headlight equal to on. And to get the alternating pattern to happen, I set my passenger headlight equal to off. And so now my status variable is just sitting there doing on off. So yeah, so one goes on when the other goes off, and the other goes on when the other goes off. So it's just a different way of thinking about things, and it's new to the AiM ecosystem, is this type of logic building, and you can really kind of walk down a serious rabbit hole here.
And do so much. It's interesting, the priority. When I first saw that in the software, when we were just talking about alarms, right? And maybe you were changing a color of a water temperature from blue when everything was normal or green to changing it to orange. That was when we first started to see and find the importance of the priority of making sure that the last one is on top, right? The one you want is the priority level. As the temperature goes up, it puts the orange on top. Mm-hmm. And now we see the bigger depth of what they were thinking, and the use of these into things that you're doing here in the PDM becomes even more important. But if you've been using the software, especially in alarms for any time, you've the same exact look and feel of priority, at least from more important here, but it's the same look and feel and understanding of prioritizing your commands.
Absolutely. And the logic has changed. So we try to keep it as close to what everyone knows is
Yeah.
possible, but add new tools and feature sets. So if let's see, I think I have like a pumper speed maybe. Yeah, pumper speed. So here is another
There's
example
complex one, yeah.
of using a pulse width modulation. So here I'm looking at my pumper speed switch, so I know immediately that that's on the keypad. And when this button is in its different states, 25, 50, 75, and 100%, I'm setting a stacking duty cycle. So when it's 25, it's 25, unless it's 50. And then we're going to up it to 50%, and we're going to disregard this message here because it has a lower priority.
Because of the priority. Yep.
Yep. And we just walk up this list until we get to 100% duty cycle.
Okay, perfect. I've got one more question here as we kind of bumping up against the top of the hour. Eldon asked the question, is there a way to send a PID to an ECU and decode the response?
Yes, yes.
Yes.
Yes, there is. What you're going to run into is multiple PIDs. If you want to send 2 messages, there's no timing structure in CAN output for you to hold a message until you receive the answer from your previous message. So it becomes, yeah, if you want 1 PID, sure, it's not a problem. You could send the request to the request ID and process the information on the way back. But I can't put in an if statement that says only send this message if we've received a confirmation of the previous message.
Okay. So it's there, but it's fairly basic.
Yes, and you run into 10 or 15 requests, and we're sending them sequentially. So as soon as one's done, the next one gets sent, and so that's on the millisecond period. And some ECUs can buffer all of this information and hold it until they can have a chance to respond, and other ECUs cannot. The appropriate way would be to set a respected timing so that you're waiting for a response back before your next message is done, and you just don't have those tools yet.
Perfect. I hope that helps a little bit. The perfect. So if you would unshare your screen, and I will reshare mine. The let's see. Let's do this. Pop that over there. Perfect. I appreciate it. I appreciate all the information. I learned so much in every one of these videos, and then that it's tenfold when we start talking about the CAN stuff for me. I'm just sitting here in awe and watching and learning along with everybody else. So I really appreciate it. It's been very good. This video will be going just as soon as I can. We'll be turning this around and putting it up onto YouTube. Robbie mentions that he went through some of that fairly quickly, and we mentioned that we linked back to other videos that may have made some of this a little fuzzy at first. So you're going to have the ability to go back and take a look at what we just recorded, and jump out and watch some of those previous videos to get the context. So that will be coming just as fast as I can get it up there. It'll be joining the rest of them. We now have currently 194 videos up there. Once this one gets up there, just tons of information there. Just go take a visit there and jump into that YouTube rabbit hole that we all do sometimes, right? So that it'll be a good time. The customer support is what we do. Give us a call. Look for us at the racetrack. It's that time of year. We're all heading to racetracks, and then and of course continuing our support at the 800 number or all of our emails where we do what we can as well. So looking forward to chatting with you of any questions you may have had or were generated from this webinar too. What are we doing next? We're going to build on what we just did. A longtime friend of mine, Todd Burris, championship racer, most well known in the Miata world, the spec Miata world, national champion in a bunch of different organizations, is going to join us next week. And Todd has been building a lot of cars in his own shop for himself and for some other users and teammates. And he's installed a bunch of PDMs, and he's doing a bunch of work that Robbie has kind of described here. And what I thought would be the next step, which would be really interesting, is to bring somebody in like Todd, and let's just chat about it. Chat about what he's done, what he's looking to do, and some of the successful stuff that he's had, some of the stuff that he's struggled with, and some of the reasons why he's doing it. And I think it'll be a good time. I know Todd has been here in the chat box today, so looking forward to having Todd here join us a week from today. Robbie, of course, is gonna join us, and we're also gonna have Fabrizio, the hardware team manager from AiM in Italy, is going to join us as well. So there'll be 4 of us on here answering questions and discussing PDMs and a lot of these connections. So that'll be a very, very good topic for all of you that enjoyed today's and are digging deeper and deeper into PDMs and CAN in general. So come join us next week when we have these special folks with us. It'll be a great time. Great time. Some contact information for Robbie and myself. If you have any questions, there's Robbie's email address. It's Robbie gets lots of questions and is just a super busy and super smart guy with these things. So I'm sure he can handle a couple more questions, right, Robbie? So
Of course.
I appreciate you coming here, Robbie, and I know it's a lot of work to put these things together, but it is so helpful to so many people that and everybody really appreciates it. So is there anything else you'd like to add on our way out today?
Well, everyone, you can see my email is available. And if anything that I've done today would make your life easier, I know that this is a real work example. This had a direct need for a customer. If anybody has this direct need, I would love to send you the XC1 files that we created today, as well as the setting up of a Blink Marine keypad with the structure already built in. Just drop me an email and I can, with what you need, and I'd be happy to send it.
It was based around an off-road world, but the functionality is virtually the same, right? You might change a few things here and there, but the off-road example you used gave it even a little bit more flavor that was kind of interesting to me as well. So again, thanks everybody for coming. I appreciate it. I look forward to having everybody here next week. It's going to be more of a discussion and more of a question and answer kind of a thing. So it'll be a good time too. Appreciate everybody for being here. Thanks. Have yourself a great week, and we will see everybody here next Tuesday.